So I used to be a product designer. It's a long time ago now. Without boring you with this kind of entire journey from there to here, I now work for Hexagon. We supply technology throughout the product lifecycle to manufacturers, from design through manufacturing out into quality inspection, software and hardware products. And I'm responsible for Nexus, which is our new cloud-based platform for manufacturing. But I can tell you from my design experience that 30 years ago, we were already spending a lot of time talking about design for manufacturing or design for manufacturability. It was a topic that was so important, it had its own three-letter abbreviation, DFM. And today, we're still talking about it. And it's still an important topic, and so it should be. But what I want to explain in this presentation, something that we're hearing from our customers a lot, or increasingly these days, is that DFM is not good enough, and it's not good enough anymore. And actually what we should be doing is we should be having design working with manufacturing, not for manufacturing, not for manufacturability, working with manufacturing. And so as a starting point, this is a topic about teamwork. And so that, with that in mind, I thought I'd start with this. So maybe with a show of hands, can I just get an idea of how many people are into Formula One? How many people follow Formula One? We've got a few. We've got about 50-50. Okay, so I'm going to have to explain some of this as we go. So the first thing to say is that at Hexagon, we are very proud to be technology partners with Red Bull Racing, which is the leading Formula One team this year. And so we really love working with Red Bull. Kind of related to that partnership, I was lucky enough to be invited to Monza in Italy in September 2021. One of the things that Red Bull is famous for is their pit stop. And so Red Bull hold the world record for changing all four wheels on a car in less than 2 seconds. They've pretty much managed to reproduce that record this season. 1.98 seconds is their fastest time this season, changing all four wheels on a car. Which is pretty impressive when you think about it. And the Red Bull pit stop is often held up as the exemplar of teamwork. And so here am I in Monza, got kind of a fantastic position to see the track, to see the pit lane. I thought what I'll do is I'll take a video of the Red Bull pit stop. Maybe one day I'll stick it in a PowerPoint presentation. I can show it to my team. I can inspire them about working together as a team. And so this is what happened. This is Max Verstappen, the star driver for Red Bull Racing, coming into the pits mid-race in Monza on the 12th of September 2021. So I'm looking for a 2-second pit stop. Oh no, that was me. So those of you that watch Formula One will know that in Formula One terms, that's a catastrophe. That car was stationary for 11 seconds, 9 seconds longer than it should have been. For those of you that don't know, these cars go up to 200 miles an hour. That 9-second delay at 200 miles an hour puts Max Verstappen back out on the track about half a mile behind where he should have been. And so as he went out on the track, he's lost about 10 places. He was leading the race up until this point. And he's lost about 10 places as a result of that pit stop. Now, I had to watch this 4 or 5 times to figure out what went wrong, so I'm going to give you a hint. So as I run this again, keep an eye on the guy on the front right wheel as the car comes in. So this is at the peak of the rivalry between Max Verstappen and Lewis Hamilton, who's the star driver for Mercedes. Max is leading the race. It's going to put him in the lead for the championship for the year. And so this is a team under a lot of pressure, and they mess it up. So it turns out that the Red Bull pit stop is a terrible metaphor for team working. These guys are not working as a team at all, at least not in any sense that's of any use to or any meaning to us. What they're doing instead is they're following a carefully designed process, a process that's been designed actually over many years. It's been meticulously refined. They've rehearsed it over and over again to almost perfection. And with that process, they're able to achieve the world record. They're able to change 4 wheels in less than 2 seconds. But as you've seen in the video, the problem with something that's process-driven like this is that when something goes wrong, the whole thing falls apart. It took them 11 seconds instead of 2 seconds. It took them 5 times as long as it should have done to change that wheel, because as soon as something went wrong, they didn't know what the hell to do next. Now, just to complete the story, those of you who watched Formula One will probably remember what happened next. Verstappen goes out onto the track. About 60 seconds later, I guess Hamilton comes into the pit stop, comes in for his pit stop. His goes much more successful. He comes back out onto the track. There's just enough time for Verstappen to have done a full lap of the circuit. As Hamilton's coming out, Verstappen's pulling up alongside him. The two of them end up next to each other down the main straight at Monza. At the end of the main straight, there's a chicane. They go into the chicane, literally wheel to wheel. Verstappen's probably still fuming from what's happened in his pit stop here, somewhat distracted, and this happens. So that's Verstappen sitting on top of Lewis Hamilton. Both of them crash out of the race. Neither of them get any points. A disaster for both of them. You fast forward to the end of the season. At the end of the season, Hamilton and Verstappen are literally neck and neck going into the final race. And it comes down to literally the last lap of the final race of the season as to who's going to be world champion. The race, now, fortunately for us as Red Bull supporters, what happens is Verstappen actually wins the race, but in extremely controversial circumstances. The Formula One race director is fired. It's very stressful for everybody involved. And all of that could have been avoided if that pit stop in Monza had been just 2 seconds faster. Verstappen would have been clear of Hamilton. He'd have got the points. He'd have been clear of Hamilton as they went into the final race at the end of the season. Okay, so what has this got to do with Nexus, manufacturing, and product design? So when we were developing the Nexus platform, we started about 2.5 years ago. We went out and asked our customers, what are your key challenges in manufacturing? Because we wanted to develop a platform that was going to be relevant to them. And we heard a lot of the stuff that we've heard before. They want to shorten time to market. That also has been a pressure for at least 30 years and probably longer. Increasing need to respond to changes. We've just been through a pandemic, lots of geopolitical kind of challenges in the world at the moment. Organizations need to be able to respond more quickly. A growing skills gap. Fewer engineers coming through our universities with the skills to go into design and manufacturing. But what was interesting, and the insight that we hadn't really anticipated, was this need for new ways of working. So manufacturing organizations, especially the bigger ones, are organized around very traditional, in a very traditional way. They tend to be very centralized organizations, very hierarchical. And they need to be because they're managing very different engineering disciplines. And then in order to make these hierarchical organizations work, they're very process-driven. And so in order to kind of work efficiently, they have processes which have been carefully architected. They've been rehearsed over years to drive things through the organization as quickly and efficiently as possible. Somewhat like the Red Bull team changing the wheels on a Formula One car. And as we saw with Red Bull, the problem with that is that when things go wrong, the system can't cope. In a process-driven organization, it's pretty difficult to innovate. Processes like that get in the way of innovation and in the way of new ideas. And so what organizations were asking us for was if only there was a way that we could encourage horizontal collaboration across the organization. It's not time to dismantle these centralized organizations already. We can't throw everything away and start again, but if only there was a way of encouraging collaboration horizontally across the organization, get people to work together, push a lot of the authority away from the center down into the different siloed departments so they could make decisions, then the organization as a whole could work more efficiently, could work in a more agile way. And if a manufacturing organization can work with more agility, then you can shorten time to market. You can respond more quickly to changes. You can start to address the growing skills gap. And if you can do all of that, then you can innovate faster to solve some of the big problems, like the problems of sustainability that we see today. And so then this whole kind of notion of needing new ways of working was exemplified for me when I went to speak to an aircraft engine manufacturer. So this is deliberately a generic image of an aircraft engine to maintain the anonymity of who I was talking to. But you can imagine, this is an area for a lot of innovation, building aircraft engines. Huge problem of sustainability of flight and so on. A lot of pressure to reduce fuel consumption in jet engines to improve the sustainability of global air travel. And in fact, I mean, I can quote some stuff that's in the public domain here. Rolls-Royce have published a lot of the innovations that they are working on. So, for example, they talk about their UltraFan engine, where the fan here at the front of the engine massively increased diameter to increase the bypass ratio in the engine, so more of the air from the fan passes the engine. This helps to improve the efficiency of the engine overall. It's going to make future aircraft look really weird, by the way, when these engines come out. Engines with much, much bigger diameters sitting on the wings of the planes. Another one is, one of the beauties of a jet engine is actually it's really quite a simple design. There's a single shaft down the center of the engine where a turbine at the back of the engine is using the exhaust gases coming from the engine to drive the shaft, which drives the compressor and the fan at the front of the engine. So sort of beautiful simplicity in the design for a product that has to operate in really sort of adverse conditions. Rolls-Royce have published that they're putting a gearbox in this shaft here because, again, to improve the efficiency of the engine, they need the turbine spinning a lot faster than the fan at the front of the engine. So you want to put a gearbox in the middle of this shaft here, right where all the the heat and the heat in the middle of the engine is, in a sort of very difficult environment to operate, and it had better operate pretty reliably as well if I'm going to be sitting on a plane where this thing's in there. These are a couple of the innovations that they've published. Aircraft engine manufacturers are amongst our customers all around the world. And I can tell you that we've heard of loads of other crazy ideas like that, and a lot more about the ways that they're trying to improve the efficiency of these engines. So I was talking to the head of metrology at one of the aircraft engine manufacturers that I'm not going to name, and asking him what are the kind of key challenges that he faces. And so like all the other engine manufacturers, they're engaged in a program of innovation for their next generation engine. It's a project that takes something like 10 to 15 years to develop a new engine. And the metrologist is right at the end of the process. These are the guys that are responsible for quality inspection of parts coming out. They're using some of our technology to measure those parts and so on. And he said that their key challenge is they're working with designers who have this massive challenge of improving the efficiency of a product like this. And they're inventing all of these crazy ideas. And the metrologist sitting at the end of the chain has to be concerned about the manufacturability. How the hell do you make this thing? And he said his biggest challenge was communication. If you work in metrology, if you work in quality inspection, you've built a career there. There've been many members of his team have been working in that area for 20 years or so. They've been working in a silo, in a hierarchical, centralized organization for all of that time. The designers are the same. They've built a career in design. They've been doing that for 20 years or more or whatever, again, working in a siloed environment. And now suddenly the metrologists have to speak to the designers. And they said it's like they speak different languages. Achieving that collaboration across the organization is a real challenge in this case. And so that's anecdotal, and it corresponds exactly with the research that we did when we started developing Nexus. This, by the way, speaks to the rise of the metrologist. So one of the areas that we operate in is, again, in metrology, so offering equipment like this for doing quality inspections, measuring parts and software like this. And what we've observed as a business over the years is the increasing importance of the metrologist. They used to be the quality inspectors at the end of the process that just said yes or no as to whether a product was going to go out the door. Then we started talking about digital thread and Industry 4.0 and all that stuff. And the data that the metrologist was generating suddenly became really important. This is kind of where you make the bridge between the digital thread and what's actually really going on in the world. And then you get to a story like the aircraft engine manufacturer, and now the metrologist is really in the forefront of innovation. And so needs to be working really closely with the designers to ensure that as we're pushing the boundaries on these product designs, we're ensuring that they continue to be manufacturable. And so it's anecdotes like this and research like this that led us to develop Nexus. And so Nexus is deliberately intended to be a sort of cloud-based, data-centric platform that's kind of different to all of the others. And so up here in the top right-hand corner of my diagram, I've kind of grouped together all of what I've called the classic enterprise systems. And so up here, I've put all of the PLM systems. So we've heard from Aras today. We've heard from Siemens, talked a little bit about Teamcenter in their presentation and so on. Not only the PLM systems, you might put your manufacturing execution systems up here, your MES systems. You might put your PDM systems up here. We've got a few as well. We have a simulation data management SPDM system called SimManager that would sit up here. We have a QMS system, a quality management system called ETQ Reliance that would also sit up here. And they're all what I would call systems of record. So they all exist. One of the core functionalities or the core function that they all have in common is that they provide centralized, disciplined data management. So an engineer doing a task, whatever it might be, checks data out of the enterprise system, whatever it is, does their work in it, solves a problem, checks the data back in again. The enterprise system is maintaining a history of everything that's happened, of who changed what. A really essential function. I'm not trying to suggest there's anything wrong with that. We're not trying to challenge that at all, but this is the embodiment of the centralized manufacturing organization today. This is about centralized control of an organization. And it's all about the process. It's all about everything that makes things work. It's all about the reason why Red Bull are able to change 4 wheels in 2 seconds, but it's also everything that's wrong with that as well. It's all about the kind of constraint and the centralized command and control. And so with Nexus, we've tried to build something different. Deliberately, our starting point has been a system of engagement. Nexus is much more about problems that are happening right now. It's much more about engaging with engineers in real time, trying to drive collaboration across an organization in real time, across different disciplines. And so I will just show one quick example of a solution built using Nexus, which will hopefully give a sense of how we're trying to do this. So this example focuses on the design space, specifically designed for additive manufacturing. We've seen quite a bit about additive manufacturing today, so it's hopefully a relevant example to have picked. What you'll see, in fact, I'll just switch to the next slide. What you'll see in this video are a handful of different products. It so happens they're all Hexagon products. Nexus is an open platform. We're not only interested in integrating Hexagon products. Sadly, we don't have any customers that only buy products from Hexagon, so the platform has to be open, so we're passionate about it being open. What we've done in this Nexus solution is connected together a handful of different products that engineers working through the design phase for additive manufacturing might be using to work together. So the first one that you just saw was a product called Apex Generative Design. It automatically generates the geometry for this part, so the optimum geometry for supporting the loads. As it happens, this part, by the way, is an engine bracket for a Formula One engine. That's just a coincidence as it happens, but that's what it is. So the first product was the product design. The second one that you just saw, was the build prep. So it's a product called AM Studio. It does the build prep, so it puts in all the support structures. If you're 3D printing in metal using a powder bed fusion process, you need to put support structures in place because while the part is being built, it'll collapse unless the support structures are in place. Then the third product, Simufact Additive, simulates the manufacturing process. Again, if you're going to 3D print in metal, it's expensive. There's a lot of thermal stuff going on, a lot of stresses that appear in the part while you're printing it, and so there's a lot that can happen that needs simulating in advance. So you simulate it before you before you manufacture it. And then finally you go to back to AM Studio, which is just does the job preparation, which is kind of slicing the part to generate the commands that are going to drive the 3D printer. There's also a materials database up here that's feeding data into this whole process. So, at the heart here, there's three different products. The product design that the design is using, the build prep used by a production engineer, and then a simulation product used by a CA engineer or a manufacturing simulation engineer or whatever it might be. Three different products. Some of these products have existed for decades, by the way. Some of them are brand new. This materials thing is brand new. Some of them have existed for decades. The engineers that are using these are very familiar with them. There'll be a lot of resistance to move away from the existing products they're using. This thing's up in the cloud. Some of these are desktop-based products. A kind of mix of technologies, a mix of engineers, a mix of disciplines. Now, what Nexus does is it connects all of these products together in real time. And so data is streaming in real time from one product to the next. So it initially solves the easy problem, which is how do you get data from one application to the next. But it's doing more than that. Because it's streaming the data in real time, any changes that one engineer makes can be immediately seen, immediately reflected in the applications that the other engineers are using. And so this stimulates an environment where the three engineers, the three different disciplines, can work together to solve a problem. So let's say that the third engineer simulating the 3D print discovers that there's a problem. For some reason, this part isn't going to print correctly. The question has to be asked, is that a problem with the design, or is it a problem with the production engineering, the kind of the build prep of the part? With these three applications connected together and streaming data in real time, these three engineers can work together in real time to solve that problem. They get on a Teams call together. The designer can tweak the design. You can tweak the build prep. The simulation can be running simultaneously. And so hopefully by working together in that way, they can find a solution to that problem much more quickly than the traditional method, which would be that the simulation engineer writes a report, sends it to the first guy, and they kind of go around the loop again. You keep iterating until the problem is solved. And so it's just an example. It's in a very specific space in the additive manufacturing space, but hopefully it illustrates the idea, which is engineers, we want them sitting in front of the applications that they're familiar with, looking at the world through the window that they've been using for the last decades, or whatever tools they want to choose to use, but put in place a technology that allows them to work in real time by streaming data between their environment and the environments of other engineers. And so this additive manufacturing process is focused on the design phase at the moment. I mean, you can be sure that we're going to be extending that into the quality inspection space. There's opportunities to take it into CT analysis as well, and also post-machining of 3D printed parts, and all of that's on our roadmap for this particular solution. We're building solutions across many other manufacturing processes for multiple different industries. And we're very interested to engage with customers to build specific solutions to specific problems that they have. So I talked specifically about design working together with manufacturing. The example kind of reflected that as well. Nexus is built to solve that problem. Nexus is also there to address any other collaboration issues and challenges in organizations. Like I say, it's complementary to whatever data systems are there already. And if you want to learn more, you can catch me in the break or nexus.hexagon.com. Thank you very much.